Good afternoon. My name is Master Olajide, and today we'll be discussing indices as promised. Now, what is indices? We have to know what indices is before we can be able to solve any calculations on it. Now, index in bracket indices. Index is a singular, while indices is the plural. Index in mathematics is the power or exponent which is raised to a number or a variable. For example, in a number we have 3 raised to power 9. This 9 is what we call what? The index. Now when we have multiple form, that is the plural form of index is what we call what? Indices. For instance, when we have a raised to power m, if a raised to power m equals a raised to power a times a raised to power b, this is what we call indices. So today we'll be taking some laws on indices. That is, we are to treat some laws because it is almost impossible for us to treat all the laws today. So we are going to treat some laws of indices. Now the first law we'll be talking about today is the multiplicative law. Now let x, a, b, y be variables. By now we all know what we call variables. That is, variables are those um, letters which can take place or take the values of numbers. Now, if x, a, b, y be variables, then the multiplicative law, the first law we are going to be treating is the multiplicative law. So we can have x raised to the power of a multiplied by x raised to power of b is the same as x raised to power of a plus b. Now this is a simple law on indices, that is multiplicative rule. The first thing is the number, which is a constant, they have to be the same before you can apply this law. And when you have multiplication in between it, then we are going to add the powers. We can prove this law by saying, let us have a constant. For instance, let's have a constant of 2 having a power of 3 multiplied by 2 having a power of 4. What the law is telling us is, since the number is the same and we have a multiplication sign in between it, then we are going to add the power. That is, we are going to have 2 raised to power 3 plus 4, which will give us 2 raised to power 7. Now let us do this literally without using the law of indices. That is, when we have 2 raised to power 3 multiplied by 2 raised to power of 4. Now 2 raised to power 3 is the same as 2 times 2 times 2. Then we'll say multiplied by 2 raised to power of 4, which is the same as 2 times 2 times 2 times 2. Now literally, we can now say 2 raised to power 3 multiplied by 2 raised to power 4 is the same as 2 times 2 times 2 times 2 times 2 times 2 times 2. So we have 2 raised to power 3 and 2 raised to power 4. When we add this together, just like we have 1, 2, 3, 4, 5, 6, 7. So we're going to have 2 raised to power 7. So this can come in form of any variable. That is, we can also have m raised to power y multiplied by m raised to power a. This will be the same as m raised to power y plus a. Note, the constant must be the same. Now there are instances whereby you might not have the constant, but we are still going to get there. But let us just have this at the back of our mind, that we have the constant must be the same before we can invoke that law of multiplication. Now we can move to the second law, which is the division law. Still banking on when x, a, y, b are variables, then division law is telling us that when we have x raised to power of a divided by x raised to power of y, this is the same as x raised to power of a minus y. So what this is saying is, that is, when you have a constant which is the same and you have division in between it, then you are going to subtract the index. So we can take examples like when we have 3 raised to power of 7 divided by 3 raised to power of 4. This is the same as saying 3 raised to the power of 7 minus 4, which will give us 3 raised to the power 3. Now, we can prove this to verify our law if it is correct or wrong. This is the same as, it can be written this way: 3 raised to the power of 7 divided by 3 raised to the power of 4, which is the same as 3 times 3 times 3 times 3 times 3 times 3 times 3, all over 3 times 3 times 3 times 3. Now this cancels this cancels this cancels this, and this cancels this. So we'll be left with 3 raised to the power of 3, which verifies this law. Now I'm going to end this before doing some calculations which will involve the multiplication and division. I'm going to add one more law to it, and the law is, when you have 1 over x is the same as x raised to the power minus 1. That is, this one, when you have 1 over x is the same as 1 over x raised to the power minus 1. And how do we go about this? How can this law be proven? Now, we should note that anything raised to the power of 0 equals 1. Now, since we have 1 here, we can make this 1. We can write it as a constant which will have an index of 0 of this x. That is, we can say x raised to the power 0 over x. That is, this x raised to the power 0 still means 1. According to what I wrote here, we all know that anything raised to the power 0 equals 1. So this is the same as this. Now, invoking our division rule, this is the same as saying x raised to the power 0 divided by x raised to the power 1. Now, using that law in division, that will give us what? X raised to the power 0 minus 1, which will give us x raised to the power minus 1. So that proves that this law, which is 1 over x, equals x raised to the power minus 1. So let us have a joint case. That is, we should have a question involving multiplication, division, and probably this. Now, example, simplify the following. 1. X raised to the power 5 multiplied by x raised to the power 7 all over x raised to the power 3. 5 raised to the power 4 times 5 raised to the power minus 2 all over 5 raised to the power 6 times 5 raised to the power 0. Now we can solve this. We can solve this by saying solution 1. X raised to the power of 5 multiplied by x raised to the power 7 all over x raised to the power 3. Now, invoking the first law, whereby we know that when we have the same constant and we have multiplication in between them, the power will be added. That is, we have x raised to the power 5 plus 7 all over x raised to the power of 3. And this will give us x raised to the power of 12 all over x raised to the power of 3. Now we have a division in between them. We can write this by saying x raised to the power 12 divided by x raised to the power of 3. So we are going to have the variable x raised to the power of 12 minus 3, and this will give us x raised to the power of 9. So you can see it's as simple as that. Now we have the second one, which is 5 raised to the power of 4 multiplied by 5 raised to the power minus 2 all over 5 raised to the power 6 multiplied by 5 raised to the power 0. Now we have the same constant 5, and we have multiplication in between, so we are going to have add the index. That is 5 raised to the power 4. We have multiplication, so it changes to addition, plus minus 2 all over 5 raised to the power 6 plus 0. And this will give us 5 raised to the power 4 minus times plus is what? Minus over 2 minus 2 over 5 raised to the power 6 plus 0, which is 6. Then we have 5 raised to the power 4 minus 2, which is 2, over 5 raised to the power 6. This is the same as 5 raised to the power 2 divided by 5 raised to power 6. And this will give us 5 raised to power 2 minus 6. This is the same as 5 raised to power 2 minus 6 will give us minus 4. Now this can also be rewritten this way. I think we can write 1 over 5 raised to power of 4. So, having done this, we can now treat one more example on the one that sometimes we can have a constant which is not the same, but it is very possible we have to make it the same constant so that we can have a different index. That is, for instance, we have example whereby we don't have the same constant. For instance, we have 5 raised to power 4 multiplied by 25 raised to power of, let's say, 25 multiplied by 5 raised to power minus 3 all over 125 times 5 raised to power 2. Now let's do this. Now you can see that we have 25 here, we have 5 here, we have 125 here. But all these are factors of 5, which we can simplify so that we can have a constant which is uniform. Now 25 is the same as 5 times 5, which will give us 5 raised to power of 2. And 125 is the same as 5 times 5 times 5, which equals 5 raised to power 3. So we can integrate this into this, then we can be able to simplify. We have 5 raised to power 4 multiplied by 25 is 5 raised to power 2 multiplied by 5 raised to power minus 3 all over 125 is 5 raised to power 3 times 5 raised to power of 2, which equals, now since we have the same constant, then we can now invoke the first law, which is a multiplicative law. That is, we can now say 5 raised to power 4, multiplication is here, so we add a positive sign, plus 2 plus we have minus 3. That will be in brackets all over 5 raised to power 3 multiplication, which will change to addition plus 2. And this will be the same as 5 raised to power 4 plus 2 minus times plus, which is minus 3 all over 5 raised to power 3 plus 2, which is 5. With this, we can now say this is 5 raised to power 4 plus 2, that's 6. 6 minus 3, that's 3 all over 5 raised to power 2. Now, since we have division in between this, we have 5 raised to power 3 divided by 5 raised to power 2. And this will give us 5 raised to power 3 minus 2, which is the same as 5 raised to power 1. And 5 raised to power 1 is the same as 5. So, in our next class, we are going to discuss some other laws. We still have about 4 to 5 laws on indices. I guess with this, we can lay our hands on more questions. And if you have any difficulty on any question you lay your hands on, I will definitely solve it and we'll do it together. Thank you very much for your time. We'll meet again.